So, memory fault models or SRAM memory fault models. So, the first one is what is called a cell stuck at 0. What does it mean? The cell can be in two states, 0 or 1. A good cell if it has, let us say, stored as 0, then when you write a 1 it goes here, and when you are in state 1 if you write a 0 it will go here. If you do a write 0 it will stay here, if you write a 1 it will stay here. Of course, reads will not cause it to change state. If you try to read a 0 or read a 1, it is not going to change state, it will stay in the same state. But if it is a cell which is stuck at 0, if you write a 0 it will remain there, but if you write a 1 also it will remain there. It is not able to write a 1. So, it does not reach the state at all. So, cell stuck at 0. In the same way we can have a cell stuck at 1. Sometimes what could happen is the cell when you power on, it may come up in either 0 or 1. See, it may come up in state 1. See, we cannot control what is the state of the cell at the time of power up, that is purely random. So, it may come up in state 1, and if you write a 0 it will come here, if you write a 1 it will stay there, but if you write a 1 here it still writes this. So, this is known as a transition delay fault. That means, it is possible for this cell to be in state 1 at the time of power on, and it will actually stay in 1 as long as you keep writing 1s. Okay. Even if you write a 1 on top of it, it does not get corrupted, but the moment you write a 0, after that it is unable to transition. So, this part is missing. So, in the same way it could have a transition delay fault where in the beginning it can come up in state 0 at power on, and if you write a 0 it will stay there, if you write a 1 it will go here, after that it cannot come back to 0, it will stay here, whether you write a 1 or you write a 0 it will stay here. There is no way to return back to this. So, this is also a transition delay fault. So, we have stuck at faults. So, when we say cell stuck at 0, it is slightly different from a wire stuck at 0. The entire cell stores a 0, but we are not able to make it store a 1. So, there is some problem in that particular cell, some defect. It is difficult to say what the defect is, but the cell behaves as though it is stuck at 0 and it is unable to change state. In the same way, we could have transition delay faults. Then because the cells are very close to one another in the array, there could be what is called as coupling between cells. So, coupling can occur. So, if two cells I and j are there, there could be 4 possible states: I equal to 0, j equal to 1. I and j are cells, let I, j be cells. They could be in state 0 1, they could be state 1 0, they could be 1 1. Then how does the good circuit behave? A good circuit, that means there is no fault in these I and j. Then if you write a j equal to 1, write 1 into j, it will go here. If you write 1 into I, it will go here. If you write a 0 into I, it will stay here. If you write a 0 into j, it will stay here. Having come here, if you write a 0 in j, it will go back. If you write a 0 in I, it will stay here. If you write a 1 in j, it will stay here, and so on. If you write a 1 in I, it will go back. If you write if you write 1 in I, it will go here. If you write a 1 in j, it will go here. If you write a 0 in I, it will go here. And you can add the remaining things. Okay, if you write a 1, it will stay here. Okay. Similarly, write 1 here or write 0. Okay. So, this is how a good circuit behaves, but there could be a coupling fault because of which there is some interaction going on between the two cells. So, there could be an aggressor and a victim. So, if you try to write something into I, it may cause j also to change. If you try to write a 1 here, this may also get written with that 1. So, it will not behave like this. This is a good circuit. So, it will not behave like this. So, when you say 0, that means state 0, state 1, state unknown. A means A is a memory address. There could be an AND bridging fault, address decoder faults. So, this is the notation. There could be a dynamic coupling fault, idempotent coupling fault, inversion coupling fault. See, it is all up to you how you want to, how many kinds of faults you are willing to define. So, let us go through some of these. This is not given now. So, unfortunately, here it is. So, we already saw this. Okay, this is a good cell. If there is a stuck at 0 fault, it behaves like this. If it has a stuck at 1, it will behave like this. This is a transition delay fault. We already saw this. Let us look at coupling faults. A transition in bit j causes an unwanted change in bit I. That is what is a coupling fault. And it can be very complicated. Maybe we are looking at j as a aggressor and I as a victim, right. So, let me enable the editing here. So, here there are two cells. There are two cells I and j. You try to write or do something here, right, as 0 to 1 or something like that. The transition in bit j is going to cause something in I. So, this can be thought of as an aggressor and this is a victim. There is nothing wrong if you say that look, there could be multiple aggressors. There is a cell I and there is a pattern of neighbors. Okay. So, this cell is surrounded by several neighbors. Okay. There is one neighbor to the right, one to the left, one to the top, one to the bottom, northwest, northeast, southwest, southeast, and all of them could be aggressors. Two or more of them could be aggressors, one or more could be aggressors. Maybe these two are together going to cause some aggression. Maybe it is like a specific event such as change 1 to 0 here, 0 to 1 here, 1 to 0 here, 0 to 1 here and 0 here, 1 here, 1 here, 0 here. That particular pattern may cause something to happen in J, that is this cell. So, it can be very complicated. That is called as a pattern sensitive fault. So, how the victim behaves is dependent on what is happening in the neighborhood, and there can be so many situations, right. Think about it. The neighbor can be all 0, always 1. The neighbor can be rising, neighbor could be falling, and there are how many neighbors? There are about 8 neighbors, isn't it? So, 8 neighbors So, there are 8 to the power 4 combinations, isn't it? Each neighbor can exhibit a 0 or a 1 or a rising or a falling. So, depending on what is in the pattern, what kind of pattern is around the cell can show some victim behavior. So, that is very complicated. A two coupling fault is when we look at only 2 cells at a time. Maybe we look at 2 neighboring cells only. We do not care whether we are willing to look at these as neighbors, these are neighbors, these are neighbors, these are neighbors, but we are not looking at all of these patterns. So, two coupling faults are a little bit easier. Inversion and idempotent faults. What is a idempotent coupling fault? Right? And what is an inversion fault? So, let us look at inversion and idempotent faults. See, this notation means I have two cells I and j. I is rising, okay, that causes j to invert. Or I is falling and that causes j to invert. That is this notation. So, that is why it is called inversion fault. The victim will change state or victim will undergo an inversion. So, a rising transition or a falling transition in cell j, I have written the other way around. I have written a rising transition in cell I causes an inversion in j. Okay. So, we have already seen this. When there are two cells, they can be in 4 possible states, both are 0, both are 1, one of them is 0, I is 0 and j is 1, I is 1, j is 0. We already saw this. Let us look at this guy. This is for inversion coupling faults. There are two cells I and j. If I was in state 0, if I write a 0, I will stay in the same state. If I write a 0 in j, we are in the same state, right. If I write a 1 in I go to this state. If I write a 1 in j, I go to this state. So far, so good. So, if j is going from 0 to 1, okay. So, here you can see that let us see, he considers this to be j and this to be I. So, let us see. So, we are writing a 1 here. Okay. So, j is going from 0 to 1. So, W1j, okay, W1j. So, j is going from 0 to 1 and it is causing a 0 to 1 transition in I. See, as a result both of them flipped. So, j was going from 0 to 1 causing I also to flip. Okay. So, this was unexpected. Okay. Whereas, in your previous one, see, there is no transition like this, okay. Whereas, here there is. In the same way, look at this. When we are in the 1 0 state, if I write a 1 in j, I will go here, but that will cause I also to flip. So, 1 will become 0. So, suddenly from 1 0 we are going to 0 1. So, this is an example of this is a CFIN, okay, and it is of this form. So, j is going from 0 to 1 causing I to flip. Okay. We can also have idempotent faults. here it is not that the cell is going to invert. When j is changing from 0 to 1, I goes into this state. If it was 0 already, it will stay there, but if it was 1 also, it will change to 0. It could be that if j is changing from 0 to 1, I goes off into this state, and similarly when j is changing from 1 to 0, it goes off into state 0, or if j is changing from 1 to 0, it goes into 1. So, these are the possible. So, j is changing from 1 to 0, causing I to become 0. So, this notation, okay. So, let us look at this one. Here he is looking at this fault, that means j is changing from 0 to 1. Look at this one, 0 is changing to 1 when I apply a j, okay. When W1 is becoming j, this is changing from 0 to 1. At that time, because of this fault, the I will also go to 1. So, from 0 0 it will go to 1 1, whereas here when I write W1j, okay, then the fault is, this will go off into 1. So, 1 0 to 1 1, but that is, that is how the even a good circuit behaves. See, when you are writing a 1 here from 0, when j is changing from 0 to 1, this should go to 1 1 state, okay. Even because of a fault, if it goes there, we cannot make out, okay. That is a normal, even a good cell will behave like that. And like that you may have so many, you can make up your own examples, okay. Let us do one more example. So, I have 4 cells, I am sorry 2 cells, 0 0 0 1 1 1 1 0. Let us pretend that we have this fault. This means when j goes from 1 to 0, that will happen here. See, if I write W0 here, j is changing from 1 to 0, and as a result I goes to 0. So, it is going to behave like this. Similarly, here if I write a 0, a good circuit will if a good circuit will do the following, right. I mean, if j changes from 1 to 0, I should not change, but in this, because of this fault, if I try to do a W0 on j, okay, then unfortunately it will go here. Because this changed from 1 to 0 and this 0 came here. So, 1 1 to 0 0. So, this is an example of a fault. So, it is an idempotent fault because this is not dependent on the previous state. It is always 1 or always 0, whereas in the inversion fault, it inverts, it depends on the previous state. If it is 0, it will become 1, if it is 1, it will become 0. The thing is, in memory testing, you can keep on coming up with a lot of these fault models, right. So, there are many possible fault models that one can look at, okay. CFID, CFN, right. So, these are the coupling faults. We already know what stuck cut faults are. We know what are transition faults. These are not transition delay faults, okay. These are transition faults. Then there could be no wet part insistive faults. Okay. These are the complete list of faults. Then there could be a dynamic coupling fault, CF dynamic. So, this is what it is. If you read or write in a cell of one word, it forces the cell in a different word to one word. So, the notation is this. So, these are I and J, let us say. I think this is J and this is I, right. He will accept this as J and this is I. So, if I is 0 and we are writing a 0 or reading a 0 from J, right, it forces this I to 1. Similarly, it could be that we are either reading or writing 1 into I, and if J had a 0, it will become 1. So, this means OR. There could be bridging faults, AND bridging, OR bridging. So, here is a AND bridging fault. A short circuit between two cells or lines. So, the value in the coupling cell causes the coupled cell to change. So, if you store 0 0 in cell I and J, the AND of those two will be stored. Here also cell I contains 0, cell J contains 1, but what will actually get stored is 0 0, the AND of these two. Similarly, here if I store a 1 in I and 0 in J, I will end up storing 0 0. Whereas, here if I store 1 in both of them, I will. So, here the OR, if I store both zeros, then there is no problem, but if I store 0 in one and the other one is 1, then both of them will end up storing a 1. It will not be possible to distinguish between some of these faults. Okay. When I try to See, a transition in I may also affect what is stored in J. Okay. So, what he is saying is the value in the cell is causing the problem, it is not a transition. In the coupling fault we use this notation. If I is transitioning, then J will toggle, or J is transitioning, I will toggle. But here it is not that, it is fixed value, both of them are 0. I wanted to write 0 to both of them, and because of AND bridge it worked out. I wanted to write 0 in one and the 1 in the other, but I ended up writing 0 in both of them. And so on. See, I really do not want to go into all the possible faults. Okay. There could be address decoder faults. So, the decoder we assume that the decoder will not become sequential. Okay. See, suppose I have a decoder, this is a 2 to 4 decoder. See, if there is a fault like this, then it may become sequential. Okay. We assume that that is not happening. Okay. So, we assume that this is not the case, and we assume that it will behave the same for both read and write. So, when I present a particular address, it is possible that the output is open, okay, nothing, all the outputs are 0. So, as a result, none of the cells are getting addressed. See, a decoder, a good decoder should behave like this, right? It, depending on if I decide to select 0 0, then I should get 1 0 1 0 0 0. If I select 0 1, it should give me 0 1 0 0. But because of some address decoder fault, I am getting a 0 here, I am getting a 0 here. So, that is what is happening here. The other could be that a particular cell can never be accessed, or when you try to place this, you are trying to select a particular cell Y, but you end up selecting both of them. So, for example, I could have a 1 1 situation, or I was trying to address X, then I will access X, and I will try, when I try to access address Y also it has. So, this is also a problem. All of these are different kinds of decoder faults.